Today we are going to do function operations, and honestly, this is nothing new. We are adding, subtracting, multiplying, and dividing functions. It's just written a little bit differently. So they're going to write something like this: f of x plus g of x. All that's really saying is, if f of x is this blue thing, and g of x is this pink thing, take the blue thing and the pink thing and add them together. So what do you think we need to do? You've got x squared and another x squared. That makes 2x squared. Got minus 5x. 8 and negative 4 makes 4. And that's our answer. Okay? It's really just take the f function, take the g function, and add them together. Number 2 is a little bit different. Our f function, or the blue one, is x to the 1/3. Our g function, the pink one, is 3x to the 1/3. We are adding those together. Do you see how x to the 1/3 and x to the 1/3 are exactly the same? What number is in front of the blue x to the 1/3? A 1. So we have 1 cookie plus 3 cookies. How many cookies do we have? 4 x to the 1/3. Okay, subtraction. We do have to be careful with subtraction. With the subtraction, our f function is a trinomial. Our g function is a binomial. We need to subtract all of that pink function, 2x minus 6. So the most common mistake here is that people don't remember to use the subtraction sign for every term in that second function. So really this is 3x squared. I shouldn't write that in pink, that's confusing. 3x squared plus 4x minus 6 minus 2x and then plus 6. You have to distribute that negative into that second function. Then you can combine like terms. 3x squared plus 2x, and the 6's cancel out, so it's just 3x squared plus 2x. When we multiply functions, we have to do the blue thing. Nope, that's not right. Nope, there we go. 5x plus 6. We have to multiply that times the pink thing, 4. Anyone want to make a guess what this is going to look like? 20x plus 24. Distribute. I know, that was just so difficult. All right, on the next one, we have the blue part, 2x plus 3. We need to multiply by the pink, x minus 4. We need to double distribute, or as some of you like to call it, FOIL. I hate that word. We have 2x squared minus 8x plus 3x minus 12. So 2x squared minus 5x minus 12. Okay, I don't think there's any like number 6 on your assignment because I didn't want to like burden you down too much with the assignment. But it is important to consider because this is more tied to what we're currently doing in this chapter. We have 3x to the 2/3, and we're multiplying that by negative 5x to the 1/3. The numbers we can multiply. What's 3 times negative 5? Negative 15. For the x's, when we're multiplying, what do we do with the exponents? We add them. So 2/3 plus 1/3, what's that going to be? It's going to be 1. 3/3, which is 1. So this is x to the first. Do you really have to write the exponent of 1? Nope, it's just negative 15x. Okay, for dividing, we're going to change a couple of these examples. We're changing number 8 and we're adding an additional one just because I want you to see an additional problem like this. So for division, we are going to do the f function divided by the g function. The f function is 3x minus 6. The g function is 2x. Here's the good news. That problem is basically done. We don't have to do anything with it. The bad news is, one of the biggest rules in math is that a denominator cannot equal 0. So I'm going to write in here, cannot equal 0. So normally, the f function and the g function, both of those would have the domain of all real numbers. Like you can plug anything into 3x minus 6. You can plug anything into 2x. But when we create a new function, we're actually creating this h of x function. In this new function, we can't use every single value of x because there's a specific value of x that is going to make the bottom of this equal 0. 2 times what is 0? 0. So we have to add in here, for this particular function, x cannot equal 0. So anytime you divide functions, you have to look at the bottom and think, what would make the bottom equal 0? And then put a little side note, x can't equal that thing. So now let's look at number 8. We would do the f function, 8x to the 3/4 over the g function, 2x to the 2/3. This one we can simplify. What's 8 divided by 2? 4. And then for the x's, when we divide, we subtract the exponents. So we need to do 3/4 minus 2/3. And we may need our handy dandy calculators for that.
1/12.
1/12. So this will be x to the 1/12. In this particular problem, we don't have to do a x can't equal whatever, because once you simplify this, there is no x on the bottom, so everything is fine. Now for this extra problem. We have 2x minus 1 over 5x plus 2. We need to figure out what x can't equal. So we need to take this bottom part and think about, when would 5x plus 2 equal 0? Subtract 2 on both sides. 5x equals negative 2. And then what? Divide by 5. When x is negative 2/5, the bottom will equal 0. So x cannot equal negative 2/5. When you're dividing functions, think about when would the bottom equal 0, and then put a little side note, x can't equal whatever that is.